So we've talked a lot about in this chapter how you graph certain things. Now we're actually going to talk about how you define certain equations so that when you have certain information, you can graph it at any point. At this point, all we've done is how you take certain information and graph it. Now we're going to talk about how you specifically graph or define an equation for it. And what we're going to talk about is specifically how you find an equation using specific information. And the first thing you're going to use is if you have a point and a slope, and your goal is always to write something in this form, y equals mx plus b. Now, from earlier in this chapter, we've talked about these two things as slope and y-intercept, or the ratio of how a line changes vertically to horizontally, and the point at where the line hits the y-axis. But what I'm going to talk about today is a new formula that you probably have only seen once in probably Algebra 2 and once in only Algebra 1, and this is called point slope. And the reason that it's so nice to use is because it uses exactly what it says. It uses a point and a slope. So if you are given a point, which I'm going to call x1, y1, and a slope, which is m. It's much like the equation for slope-intercept up here, but we have a different formula, and you'll see how I use it and why it's so effective. The equation for slope-intercept is y minus y1 equals m times x minus x1. Now, you might be asking yourself, why does this formula work, or where did this formula originate from? And I can tell you that this originates from the equation for slope. But if you want a actual long definition, I can explain that to you in class. But we are going to use this, and this is my point, and this is my slope. So what I need is a point and a slope, and we're going to use that information to then help me find the equation of a line. So I'm going to show you how this can be done. So it says, find the equation of the line that contains this point with a slope of -3/4. So here's my point, here's my slope. So in terms of the equation, y minus y1 equals m times x minus x1, I'm going to plug in -1 right here. I'm going to plug in my slope. So I'm going to plug in -3/4. And then I'm going to plug in 4 for x1. Now you noticed I put parentheses around it all just because of this minus sign here, because you're going to see that sometimes you're going to deal with a couple minus signs and they cancel each other out. So what we have is y plus 1 equals, I don't necessarily need the parentheses there. I don't need these parentheses, so I'm just going to get rid of this. And now I have this -3/4, and I want to get rid of that parentheses by distributing. So I'm going to take -3/4 times x. I get -3/4 x. Then I take -3/4 times -4, and I get a +3. If you don't believe me, it's -3/4 times a -4 over 1. That's going to be a -12, or excuse me, a +12 over 4, which is 3. So we have this equation here. You might ask, well, what do I do with this now? Well, I'm just going to rewrite this up here. We want to solve this for y so that we have a nice equation that has a slope and a y-intercept to graph. So in order to solve this for y, we have this plus 1 that we have to deal with. So I'm going to subtract 1. And notice we have this plus 3 on the other side. So I'm going to minus 1 to the other side. Okay? So what I have left is y equals, I didn't have anything to combine with this negative 3/4 x, so I'm just going to leave that alone. And then I'm left with plus 2. So the equation of my line is written right there. So there is my answer. Now I'm going to skip the next problem because I want to talk about another problem real briefly before I get into this one. Okay. So I want to talk about this one that says find the equation that contains this point and has a slope of 2. Now, if you can recall, now I don't need you to write this down, but if you can recall from way back when you did this, you probably did something like this. You plugged this point in for x and y and used this point for m and then solved for b. You probably did something like this. And again, you don't have to write this down, but you probably plugged in 4 and you probably plugged in 2 and probably plugged in negative 2 and had a b here and you had to solve it. Okay? I'm eliminating that so we don't have to do two different equations. What I'm trying to do is I'm trying to write a different equation so that we have an equation at the end so we don't have to use it, solve it for a different one. So what I'm doing is using this equation so that our final answer is what we need at the end. So my y coordinate I'm going to plug in here. So it's y minus 4 equals m times x minus a negative 2. So instead of minusing a negative 2, you could just make that a plus 2. So I'm just going to rewrite this as y minus 4 equals 2 times x plus 2. Now I want to get rid of this parentheses, so I'm going to distribute to both of these. So I get y minus 4 equals 2 times x plus 2. Oh, excuse me. What you're going to get is y equals 2x plus 4. I'm going to solve this by adding 4 to the other side. And I get y equals 2x plus 8. There's your line. Your line is right there. So we've talked about how you do this if you have a point and a slope. Now what I'm going to show you how to do is if you have 2 points. And the difference isn't very much. The only difference is that you have to find your slope. And when you have to find slope, we have 2 points. We need to use the equation to find slope to do this, which is y2 minus y1 over x2 minus x1. So if you have 2 points, you got to find slope first. So I'm going to find the slope first. I'm going to take 1 minus 3 over 4 minus 2, which is going to be a negative 2 over a positive 2, which reduces to a negative 1. So my slope is negative 1. Now, it doesn't matter in terms of the points that I choose which one I use. You might be saying, well, in terms of this equation, I have 2 points. I need to pick the right one. Well, the nice thing about this is that since both of the points are on the line, it doesn't matter which one you use because both of them are on the line, both of them work for this. So I could use this one or this one, and it doesn't matter because both of them will give me the same equation. So I'm going to say y minus 3, which is my y coordinate, equals negative 1 times x minus 2. I'm going to distribute that negative to both terms. So I get y minus 3 equals negative x plus 2. I'm going to add 3 to both sides, add 3 to that negative, or to that positive 2, and my equation is going to be y equals negative x plus 5. And there's my equation. So looking at something else here, this is actually going to come in and deal with both of the problems like you see here with this one and the one that I kind of skipped. Okay? So the first thing you need to do is find the slope. So I'm going to find the slope since you need that to define an equation. So I'm going to take my second y coordinate minus my first one over 2, my second x minus my first one, which is going to be 8 over 0, which is, it's not going to be 0 because you can't divide by 0, so this is actually going to be undefined. Okay, so the slope is undefined. And in terms of a visual picture, so what we have here is a line that goes through this point and that point. We have a line that goes straight up and down. I know it's not perfectly drawn, but it goes straight up and down through these 2 points. So this is an example with an undefined slope of a vertical line. Now, when we talked about this in a previous section, a vertical line is defined by where it intercepts the x-axis. This intercepts the x-axis at x equals 2. So the equation for this line is just x equals 2. So if we're talking about a undefined slope up here, and it goes through the point 9, 2, if it's undefined, that means it goes straight up and down. And it's defined by where it goes through the x-axis, and it goes through the x-axis at 9, so there's my line. That's all you need to write. Undefined slopes happen to be vertical lines, so that's all you can write for vertical lines. They don't act like other lines, so you have to write them as x equals whatever their intercept is. In the second part of this video, I'm going to talk about this application problem at the end of this section.